Hi class, in this lecture here we're going to introduce what's called the polar coordinate system. And what we're going to do, what we're going to work through in this lecture, our objectives here, is basically we want to talk about how you relate the polar coordinate system to the rectangular coordinate system, which is what we're used to working in, okay? So what we're going to talk about first is how you plot points in this thing called the polar coordinate system. So I'll define it and attempt to explain it. And then we're going to do all these conversions. We're going to talk about how you convert a point from polar to the rectangular coordinates, how you convert a point from rectangular to polar coordinates, and then how you convert an equation from rectangular to polar coordinates, and then how you convert an equation from polar to rectangular coordinates. And this lecture is just going to be filled with a ton of examples. Okay, so as I'm going through the lecture here, what you might want to do is, as soon as I put up an example, maybe pause the lecture, give the problem a try, and then see if you get the same thing that I do when I solve it for you. Okay, so let's start off by talking kind of briefly, giving a basic concept of what this polar coordinate system is. And what I have here in the slides for you is I have the unit circle both in radians and degrees because I'm going to use it a little bit throughout the lecture, so I wanted to have it referenced here for you. All right. So the foundation of the polar coordinate system is a horizontal ray that extends to the right, okay? The ray is called the polar axis, and you can see it down here, okay? The endpoint of the ray is called the pole, right? So think of it here. I have this pole, right? And then I have this ray that shoots out from that pole, okay? And this is our polar axis. It's this horizontal ray. All right, a point P, and you can see here, I have this point P in the polar coordinate system, is represented by an ordered pair of numbers, just like the xy, okay, in the rectangular coordinate system. But here, our ordered pair is going to be r and theta, okay? And we refer to the ordered pair P is equal to r theta as polar coordinates. And hopefully you can kind of see what's going on here. Like, if I draw from the point down here, I can kind of get a right triangle. And you can see how we're going to start relating trigonometry to this. Here's my angle, an interior angle here of the right triangle, and you can think of r as the hypotenuse of this right triangle here, okay? Or another way you can think about it is if I were to draw a circle, all right, centered at the pole here, r would be the radius of the circle, okay? And theta would be, just that angle here if I were to draw the right triangle from that embedded in the circle, how we relate it to the unit circle. All right, so in the ordered pair, P is equal to r theta. R is the directed distance from the pole. That's important, directed distance. Okay, so r can be positive, negative, or 0. All right, so like here, this would be a positive r. All right, and then I'll do examples about when r is negative here. All right, we'll go through that. And theta is an angle from the polar axis to the line segment from the pole. All right, the angle is measured in degrees or radians. I'm going to mostly stick with radians in class today, or in this lecture. And positive angles are measured counterclockwise. Okay, so counterclockwise like this. All right, from the polar axis. And negative angles are measured clockwise like this from the polar axis. All right, so basically what you're doing is you're saying, okay, I'm going to give you theta. I'm going to tell you, the degree here, and then I'm going to tell you r, the distance for it, okay? So this is just another way to represent an ordered pair. So instead of x and y in the rectangular coordinate systems, we're going to use r and theta here. So let's talk about how you plot these. Okay, so plot the following points with the following polar coordinates. Okay, so remember, this is r and theta. Okay, so the directed distance and then the angle here. All right, so one way that I like to show you how to plot these, it really helps, is I start drawing circles, okay? And this is a circle of radius 1, this is a circle of radius 2, and a horrible circle, but you get the idea. And this is a circle of radius 3, okay? So look, my point has an R3, okay? So my point is going to fall on this third circle out here. And all I'm going to do is I'm going to go 315 degrees. So if you look, if you go back to here, this is why I have this here. 315 degrees is right here, right? It falls right in the middle of this fourth quadrant here. So you're going to go 315 degrees and right here. Okay, so that right there is the point 315 degrees, right there. All right, let's try this one now. So stick with the circle, okay? I hope that makes sense, all right? Here's a circle of radius 1, radius 2, radius 3. These are terrible circles, but you get the idea. Radius 4, and a circle with radius 5. All right, so pi over 4, right? So if you need the it's a 45-degree angle. If you need help here seeing it, it's right here. And it's going to be, okay, on that fifth circle out there. So 1, 2, 3, 4, 5. And this is in radians, 45-degree angle. So this is my point P is equal to 5 pi over 4. So again, just showing it as the distance out, all right, and then the angle that you're going to go up here. All right, let's now, I talked about r as being the directed distance. So now let me show you what happens when the r value is negative, okay? All right, so let's plot the following here, all right? -2 comma pi. All right, so remember, this is my r, and this is my theta. All right, so I'm going to draw circles again. Here's a circle radius 1. Here's a circle radius 2. All right, so I'm going to go out pi. All right, so the angle is pi, so that's over here, okay? But look, this point here, this would actually be the point 2 comma pi, okay? Because it's saying go, my angle is pi, and then my distance from the pole here is 2. But what happens is when you have a negative, the negative says, okay, go here, but then the directed distance is the opposite way. So it would actually be over here. So this is the point -2 pi. Basically what's going on here is when you have this negative distance here, it's 180 degrees in the opposite direction. Okay, that's what the negative is telling us here. All right, so let's try this one here. So I just need circle with radius 1. All right, so I'm going to start by going to the angle. So I'm going to go negative pi over 2 is here. Okay, but this point right here, this would be the point 1 comma negative pi over 2. So -1 would be the 180 degrees in the opposite direction, whoop, right here. All right, so this is the point P, which is -1 negative pi over 2. Important to note that. Okay, so the negative value here, the directed distance, tells me to go in the opposite direction here. All right, so this is just another way to plot points. So instead of the xy, you're giving the directed distance and then the angle from the polar axis. That's what's going on here. All right, now let's talk about the relationship between polar and rectangular coordinates. Okay, so I hinted at here to relate this to right triangle trig. Okay, so if you think back at the unit circle, right, the x coordinate here is the cosine of theta, and the y coordinate is the sine of theta. All right, so our conversion here is the following. Okay, all of these hold. This is the relationship between it. So in the rectangular coordinate system, the value is the radius times the cosine, or r times the directed distance r. Forgive me for always calling it the radius. R times the cosine of theta, and y is equal to r times sine of theta. Additionally, we have x squared plus y squared is equal to r squared, and we know tangent of theta is just the y value divided by the x value. All right, so to convert a point from polar, which is r theta, to rectangular coordinates x, y, you're just going to use the following. If I know r and theta, the x coordinate is r cosine of theta, and the y coordinate is r sine of theta. All right, and so what I'm going to do is I'm going to convert some values here so you can see it, and I'll actually even plot the first one so you can verify that this is true. All right, so just remember this. To convert, x is equal to r cosine of theta, and y is equal to r sine of theta here. All right, so let's convert the following points. All right, to find the rectangular coordinates here from the points with the following polar. So let's look at this one, and let me just show you this, okay? And this is how you'll be able to see it. The point 3 theta, if you draw circles, right? All right, or 3 pi, excuse me, 3 pi. All right, that's the point right here. Okay, this is the point 3 comma pi. But if you think about it in terms of rectangular coordinate system, that's just the point negative 3 comma 0. Okay, so if we go through and use this conversion here, we should get the corresponding rectangular point negative 3 comma 0. All right, so watch. My point in polar r comma theta here is the point 3 comma pi. All right, so to convert, right, so x is equal to r times cosine of theta. So this is just 3 times cosine of pi. Well, this would be 3. What's cosine of pi? Like, if you need it here, that's why I have these here. All right, cosine of pi is negative 1. So the x value is negative 3. That's what I said you would get. And y is equal to r times sine of theta. So this is 3 times sine of pi. Well, what is sine of pi? That's 0. So what you can see here, look, the x comma y, all right? So you can see the rectangular coordinate of the point 3 comma pi is the point negative 3 comma 0, which is what we said we would get just by looking at it. All right. Look, so let's just try this one here. All right, so in polar here, okay, which is the directed distance and the angle from the polar axis, is negative 10 comma pi over 6. All right. So x is equal to r times cosine of theta. Well, that's negative 10 times cosine of pi over 6. Well, look, we need to go back to the unit circle. Right? Cosine of pi over 6 right here is the square root of 3 over 2. And the corresponding sine will be 1/2. Okay. So this is negative 10 times the square root of 3 over 2, which when you simplify here, you get negative 5 square root of 3. And y, which is r sine of theta, would be negative 10 times sine of pi over 6, which is negative 10 times 1/2, which would be negative 5. So here you can see the rectangular coordinate of this point in polar, negative 10 comma pi over 6, is just this point, minus 5 times the square root of 3 comma negative 5, or negative 5 square root of 3 comma negative 5. So just follow the formula. That's how you would simply convert it here. All right, now let's talk about going the other way. All right, so from rectangular to polar. Okay, converting a polar. All right, convert a point from rectangular to polar coordinates. Okay, and so this is going to be here. This is important. Okay, r is going to be positive here. Okay, and this is going to be for theta is going to be between 0 and 2 pi. All right, so I'm going to notice something interesting when I solve here, and then remember this. What this is saying here is I want my theta to be between 0 and 2 pi. All right, so the first thing you're going to do to help you here is you're going to plot the point xy. And then all you're going to do is find r by computing the distance from the origin to xy. And all it is, the distance formula here, is our directed distance r is going to be equal to the square root of x squared plus y squared. Okay. And then you're going to find theta, our angle theta, using tangent of theta is equal to y divided by x. Okay. And this is with the terminal side of theta passing through xy. All right, let me do an example here. All right. So let's find the polar coordinates of the point with rectangular coordinates 1, comma, negative 3. So that's this point over here. Okay. This is 1, comma, negative the square root of 3. All right, so I plotted it. So we're going to find r using, just following the directions here. R is equal to the square root of x squared plus y squared. All right, so look, this is my x comma y point. So this is the square root of 1 squared plus negative square root of 3 squared. So this is 1 plus 3, obviously, right? Because when you square negative is positive, and the square root of the square of the square root just goes away, and you get 3. So this is the square root of 4. So here r is equal to 2. Okay? So this distance here, this r, is equal to 2. All right, so now here's the thing. We want the rectangular coordinate, or with the polar coordinate, excuse me, we want theta to be a positive angle here. Okay, so we want to now find this angle here. So you're going to use this. So you're going to find theta using tangent of theta is equal to, going back, look, y over x. So you have to solve this equation. Tangent of theta is equal to negative the square root of 3 over 1. So you have to figure out basically when does tangent of theta equal negative square root of 3. Well, you can use this trick. I'm going to show you two ways. You can look at the unit circle here. All right, and you can see it's got to be right here, right? Because it's y over x. So if this was y is negative square root of 3 over 2 and x is 1/2, watch what happens. So tangent here, just looking, right, going back. 5 pi over 3 here, okay? It's negative square root of 3 over 2 divided by 1/2, which gets you this negative square root of 3. But what's another way that's really interesting here, so what you can see here is what I'm saying here is the conversion is, so point is r comma theta, it's 2 comma 5 pi over 3. But what's really cool is you could also do it this way, and I wanted to show you something. If you do tan inverse of negative the square root of 3, so I have my calculator here in degrees right now. All right, so let me just show you this. If you go second function tan inverse negative the square root of 3, you're going to get negative 60 degree angle. So it's giving you this angle right here. It's saying negative 60 degrees. So you could just say, okay, well then, that corresponds to, basically a 300 degree angle. So you go back to your unit circle, 300 degree angle, boom, 5 pi over 3. So that's another way you could solve it. Just to see an alternative way. Okay, so like if you can't use your unit circle, you can use the tan inverse there to get it. All right. So that's just, you know, that's how you go from rectangular to polar. Now let's talk about equation conversions here. Okay. So what we're gonna do here is this is equation conversion from rectangular to polar coordinates. So I'm gonna give you like a rectangular equation like this, and I want to put it into a polar equation. So a polar equation is an equation whose variables are r and theta. So to convert a rectangular equation in x and y to polar and r and theta, all you're going to do is you're going to replace x with r cosine of theta and y with r sine of theta. And then what you're going to notice I'm going to do then I'm just going to solve the equation for r. Right, I want to get it into this. It's kind of like when possible. It's kind of like solving the equation for y. When possible, when possible, do that. All right, so this is the key. All right, x is equal to r cosine of theta and y is equal to r sine of theta. All right, and then simplify. Okay, and it's going to be a little tricky. Okay. All right, so convert the following rectangular equations to a polar equation that expresses r in terms of theta. So I want to just solve it for r here, okay? That expresses r in terms of theta. I just want to get r is equal to something in terms of theta. All right, so again, look. Wherever you see an x, put r cosine of theta. Wherever you see a y, put r sine of theta. So 3x minus y is equal to 6 becomes 3, and then I'm going to replace x with r cosine of theta minus, all right, so I'm going to put in for y, r sine of theta is equal to 6. Now I'm going to just express it in terms of r. So I'm going to solve for r. So I'm going to factor out an r. And then look, to get r by itself, I'm just going to divide this over. So I have r is equal to 6 divided by 3 times cosine of theta minus sine of theta. All right, now this one, okay? This one's going to be a little bit more tricky. So I have x squared plus y squared, or x squared plus, and then in parentheses, y plus 1 squared is equal to 1. All right, so let's just start. Wherever I see the x, so this is going to be r cosine of theta squared plus r sine of theta plus 1 squared is equal to 1. All right, now go through and simplify this, okay, because I want to get it just in terms of r. Or r, I want to get r in terms of theta. So this is r squared times cosine squared theta. When you FOIL this out, you get r squared sine squared of theta plus 2r sine of theta plus 1 is equal to 1. So here's what I'm going to do. I'm going to subtract 1 from both sides, okay? So, you know, this basically the 1's go away. And then I'm going to group these two together right here, all right? And I'm going to factor out an r squared. So I get r squared times cosine squared theta plus sine squared theta plus 2r sine of theta is equal to 0. Well, look, what is your trig identity here? Cosine squared theta plus sine squared of theta is just 1. So you have r squared plus 2r sine of theta is equal to 0. Weird. Like, what, you know, what am I going to do? You know, let me factor out an r. And then I have r plus 2 sine of theta, r times r plus 2 sine of theta is equal to 0. So look, I'm going to set, I have two things multiplying to be equal to 0. I can either have r is equal to 0, or I have r plus 2 sine of theta is equal to 0. Well, this has no terms of theta, so I'm just going to not worry about that. to solve this, it's just r is equal to minus 2 times sine of theta. So I was able to get r in terms of just theta there. Right, so it's, you got to trust the process. You got to go through, simplify, 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 and then just get r in terms of theta there, if you can. All right. Now, this is where we're going to spend a lot of time. I have 4 examples of this so you can see. All right. This is converting from polar to rectangular. So when we convert an equation from polar to rectangular coordinates, our goal is to obtain an equation in which the variables are x and y rather than r and theta. So we want to get rid of r and thetas. We just want everything in terms of x and y. And so we're going to use one or more of the following equations to do it. Okay? So one is that r squared is equal to x squared plus y squared. That's something we can plug in. R times cosine of theta is equal to x, and r times sine of theta is equal to y. And then tangent of theta is equal to y divided by x. All right, so to use these equations, it's sometimes necessary to square both sides, to use an identity, or take the tangent of both sides, or to multiply both sides by r. So I'm going to do one example of all of that, okay, so you can see. All right, let's jump in here. All right, convert the polar equation to a rectangular equation in x and y. So here it's just r is equal to 4. Okay, so what are you going to do here? Sometimes it is necessary to square both sides. So let me start with that. Let me just square both sides. So I have r squared is equal to 16. Well, look. What is r squared is equal to? R squared is equal to x squared plus y squared. So wherever I see, now I can substitute in for this. So x squared plus y squared is equal to 16, all right? And this is because r squared is equal to x squared plus y squared. And look, done. I've got it just in terms of x and y. And so look, what does the graph of r is equal to 4 look like? It's just a circle with radius 4. It's saying, that's what it looks like here, okay? And you can see that here. We'll cover this when we talk about conic sections in a follow-up video, but this is just the equation of a circle centered at 0, 0 with radius 4. All right, let's try this one here. All right, convert the polar equation to a rectangular equation to x and y. So my polar equation here is just theta is equal to 3 pi over 4. Well, look, let me take the tangent of each side here, okay? So I have tangent of theta is equal to tangent of 3 pi over 4. This is what's great here. Tangent of 3 pi over 4 is just negative 1. So I have tangent of theta is equal to negative 1. So it's like, well, Matt, that's great. You know, how does that even help us? Well, look, whenever I see a tangent of theta, I can plug in y over x. So replace tan theta with y over x. So I have y over x is equal to negative 1, or solving this, I have y just for y is equal to negative x. So look, this is what this looks like. The equation y is equal to negative x is just a line like this. And so look here, this angle here is 3 pi over 4, and then basically for any r, if r is positive, it goes out here. If r is negative, directed distance is that way. So that's what this looks like. All right, let's do this one. Convert the polar equation to a rectangular equation in x and y. So here's where you're going to need an identity. All right, r is equal to -2 secant of theta. Well, what is secant, right? Secant is 1 over cosine. So r is equal to -2 over cosine of theta. Well, it's like, okay, well, I got an r and a cosine. R cosine, if I can just get r times cosine of theta, that's equal to x. So let me cross multiply here. So I have r times cosine of theta is equal to -2. Now replace r cosine of theta with x. So this is just the equation x is equal to -2. So that graph is just, straight line like this, or a vertical line like this. Boom, we got it. Okay, so let's talk about what we've done, right? We've squared both sides, we've used an identity, we've taken tangent. Now let's talk about an example where you have to multiply both sides by r. All right. So I have this. Let's convert the polar equation to a rectangular equation in x and y. And this is where r is equal to 10 times sine of r. Okay. So multiply both sides by r. So I have r times r is equal to r times 10 sine of theta. So this is what I have. This is r squared is equal to, I'm just going to rearrange this. I'm going to write this as 10 times r sine of theta. Why did I do that? Well, look, r squared going back, we know is equal to x squared plus y squared, right? And what is r sine of theta? That's just y. So we're going to sub in r squared is equal to x squared plus y squared. And y is equal to r times sine of theta. So this, the left-hand side becomes x squared plus y squared is equal to 10 times y. All right, so I'm gonna, obviously we got rid of the r and theta, but I'm gonna subtract the 10y over. And now here's the thing. If you complete the square here on this, take -10 divided by 2 squared, you get 25. If I were to add 25 to each side, this here is a perfect square, and it just becomes x squared plus y minus 5 squared is equal to 25. Well, 25 is 5 squared. So the graph of this is just a circle with radius 5 centered at the point 0, 5. Oops, sorry about that. All right, center, radius 5, and center 0, 5. We're gonna talk about that in when we talk about conic sections. All right, but for now, I hope this was a good introduction for you. A lot of examples, and we'll follow this lecture up with a very, very brief lecture talking about sketching the graphs of these polar equations. All right, class, as always, if you need anything, I'm here for help.